So we have found the rate law for the overall reaction this last kinetic section by looking at the data and comparing two different trials and figuring out how the concentration of the reactant impacts the rate. And that's one way to get the rate law for the entire reaction. The other way is to look at the 2 steps or 2 or 3 steps, the mechanisms. Remember, the mechanisms are the steps by which the reaction occurs. And usually the first one we said was slow, and that really determines the rate. And the fast one is almost instantaneous. So it really doesn't impact the rate. It's too fast. So on the review, you might be asked on a couple of the questions to write the rate law for each step. So if you were to do that, you would look at the reactants on step 1. So it would be rate equals K NO2 to the first order, because we're taking that coefficient. When we get down to individual steps, not the overall reaction, but on individual steps, we can use the coefficients as the order. And then in the second step, which we know is our slow step, we would write rate equals K, and we would have NO to the first and O3 to the first, again, taking those coefficients. So we have the rate for each of the reactions. This second step, though, which is almost instantaneous, really is not going to impact the rate. And the other reason why this second rate law is not going to be correct for the overall reaction is we have an intermediary. The NO is an intermediary. It was formed on the first step, used on the next step. So it's not one of those original compounds that you put into the reaction that it should be in your rate law. So for those 2 reasons, we're going to get rid of that one. And then this rate law should be the rate law for our entire reaction. It's okay that we have a catalyst. Remember, anything you start with and then you end up back with, that's a catalyst. It's okay for NO2 to be in the rate law because it's a catalyst. It does change the rate of the reaction. And the reactant CO is okay to be in the rate law. What we're not seeing is O3. So if we don't have O3 in the rate law for the overall reaction from that slow step, O3 is going to be a 0 order. Remember, 0 order means that reactant comes in the fast step, and it's just such a fast step, it doesn't really matter how much O3 you have. It's not going to change the rate of the reaction significantly. So our O3 would be a 0 order, and if you want to, you can include it to the 0 order, but you don't have to because anything to the 0 power is 1. So that's how you write rate laws given the rate mechanisms, the steps of the reaction. And you would get the same rate law as if you were looking at the data and kind of comparing trials and looking for those orders. Okay, thank you.